Hi guys, ladies and gentlemen. So here we are at the Omega CN7500 excuse me, controller. It does a wealth of controlling. It does ramp and soak. It does PID, set point, on off, heat and cool. Quite a mouthful. Let me turn it on over here. Alright, so let's see what's going on. There's your enter button. There's your index button. There's your up down button. So this thing must have a set point. 55.0, 55.1. You press enter to lock it in place. Alright, let's find out what we can do with this thing. Now to enter the initial menu, you press that leftmost one for 3 seconds. Then you get your initializing menu. Input is 100 ohm JPT, which stands for 100 ohm platinum resistor, I think. What other some? It's got a whole myriad of choices. PT also 100 ohm platinum resistor. Anyways, we'll just keep it at what it was. Oops, what happened? Not involved in that yet. Let's go back to the initializing menu. So I'm going to press that 3 times, 3 seconds. Okay. Input JPT, fine. Temperature units, degrees centigrade. They could have been degrees Fahrenheit, but we'll keep them at degrees C. Moving along. TP high 400.0 centigrade. Temperature low limit -20. Again, you can change those. Control. Currently it's at PID. Could have been on off like a refrigerator. Could be nano, don't know what that is. Or it could be your program. Let's just stick to PID for a second. Well, we'll make sure it's locked into place at PID before. Moving along. SHC, heating or cooling? What's being controlled? We're going to heat it. What else could it have been? Cool, that makes sense. Or it could have been heat 1 and cool 2. Or it could have been heat 2, cool 1. That's right, folks. This thing can control a process where if it gets too hot, it can cool it down to the set point, or if it gets too cold, it can heat it up to the set point. Pretty nifty, but we're going to just stick to heat right now. Press enter. Let's keep going. Let's see what else we got out there. Alarm 1. All right, you better go to the manual for alarms. I just don't know much about them. SALA. Oops, don't know what that means either. What are our choices? Oh, we could have alarm 1 or off. Not sure what it is, so we'll just make sure it's off. Okay, moving along. Co-SH is off, but what could it have been? It could have been on. Alright, so I need to write down stuff I don't know what it is. What is Co-SH? We'll look up in the manual. I'm going to type into Google Omega CN7500 manual. We'll just leave it off. Moving along. Oh, this is getting into the serial communication with this thing. I'm going to just skim through that. ASCII C-no, don't know. BPS bauds, bits per second. 9600 baud. Word length of 7. Parity even. Stop is a 1 bit. And we're back to the top. Input JPT. So we're going to get out of our initialized setup by pressing this. There, now you see a set point and the actual temperature and the set point. All right, what else can we do? Now we did a long 3-second press. What if we do a short press? We see we are in PID 3. What else could we? And it has a value. Oh, the set value, 55 degrees. And the set value at PID 3 is 55 degrees. P is some number, 9.9. I is some number and finally D. And it also has a couple of other things. I offset for a group set. For 3 is that. Heat period, very interesting concept. So this thing over the course of 15 seconds will blip on and blip off for a certain amount of time to do the heating. There you see is a cartridge heater, and there is the PT100 there, the smaller item, dunked in the water, ready to do its process. And this gadget in here is just keeps all the wiring inside. You got one outputted to that cartridge heater and one going to plug in to get some power. And over here is our PT100 going out there to collect your temperature data. Heat period. So this particular unit has an internal relay, clicks on and off like a switch to provide power to your heater. So over the course of 15 seconds, I could have, that's my job here to change it. Let's change the period to 21 seconds. Great. So now over the course of 21 seconds, it'll blip on and blip off one time during those 21 seconds. Heat period. All right, moving along. Temperature offset. So if my Chinese PT100 differs from reality, I'm allowed to create an offset. Let's see, it can go positive. Let's see if it can go negative. Yep, it can go negative. So there you go, offset. Now let's see if this thing actually works. I'm going to change it to some fairly big offset. Fine. 21 degrees offset is not insignificant. All right, well, let's just get out of here and see what our new set point looks like. Our new set point is 51 degrees of the process value. So definitely you're adding that 20 degrees to the 30 degrees. And let's jump right back in and change our offset. Now, this gadget has PID 0, has 0, 1, 2, and 3, and even a fourth choice. But 0, 1, 2, and 3 is where you can actually collect PID values. So let's go ahead and move that. Oh, it didn't do any good. All right, well, let's just carry on the mission of getting to our offset of 21 degrees and getting that back to 0. There. Let's quickly scan through what other choices we got here. PID 3. Stuck at PID 3. So that PID 3, if I change the set point at PID 3. Oh, it is changing the PID choice. So let's go back to PID 0 and let's put a set value of something a bit lower. And these things are hard to press. Oh, it's not hard to press. This is just changing the PID choice, not that actual number. So let's enter that. PID 0. And let's just go see what we got now. See the sub 0 or SU 0. That's the set point. Oh, that's what I want to change. The set point of the PID. I want to change that set point, which it does allow me to do, if it would. $32. Let's choose. Let's choose 40. $40 for your set point of PID 0, or enter that in. Great. Now let's just get out of here. So we'll just press that again. I think that gets us out of here. Yeah. So now we're back to set point and process value, but it's not on yet. So now we press this button here, and we see it allows us to see run stop. What else does What else does it allow us to see? The decimal point is kind of thrown in there. Lock on or off. I don't want to lock it. So not too many choices either. Just run stop. How many set point decimal place and lock on or off. So I want to go ahead and let's run it. So we're going to go over to our arrows. What's our choices? We could run it. What else could we do? We could run it or stop it. So currently that's all our choices. So let's go ahead and run it. We're going to press enter. Now right here, out 1, we're going to watch what happens. If we press run, is it going to really start to work? Let's do it. Oh, it did. See, it's running now. It turned on the output 1. And let's see what's going on. So I press that to get to our main screen. Oh, look at that. It's cycling on and off. So it's trying to get 29 degrees up to 55. But what else can we do now? Let's press this button here. Run stop is running. Nothing I can do there. So there's one new thing. Run stop is run. Decimal point. Lock off. But now I see out 1 and 42.7%. I think that means like the duty cycle. May be wrong. Anyhow, let's get back to the main screen. And now let's try this. Short press. Auto tune is off. Okay, well that's interesting. What else can we have? PID 0 is 40 degrees. So we want to calibrate. Let's auto tune PID 0. So since we have chosen 40 degrees, set point of PID 0 is 40 degrees. So that this thing can auto-tune the P0, I0, and D0. Oh, look at that. Stop that horrific flashing. So the computer and my cell phone seem to do... Never mind, it's back to flashing. Anyways, let's set our set point to the same set point of that PID set of 40 degrees. Whether or not it matters. There. Press enter. Alright, so we're going to now do run stop is running, but now this time next not of any help. So that button's no help. Let's go to this button. Press short press. Auto tune off. Well, guess what? Let's tune up those numbers. So we're going to take it on. Press enter. Now notice, look at that. AT is flashing on. That means shut up and let me take control. It is now going to take control. You see it's got the output on, and it is probably going to observe things. So great, it's on. No need to sit there and look at the fact that it's on. We'll go back to the screen. Alright, so now the system will be tuning itself for PID 0. And we could also... So the nice thing about the PID 0, PID 1, PID 2, and PID 3 is you can get the PID values around a particular set point. So if you go back and set it to that set point, it will know that system at that set point. That's my system. Now, once you get PID 0, 1, and 2, and 3 all auto-tuned up, you now have the choice of letting this thing choose what's the best set of data, either PID 0, 1, 2, or 3. And you do that by, well, right now it's auto-tuning. I don't really want to. But if you set it to PID 4, PID 4 is not another set of data. Instead, it just tells the unit, this is the unit, it tells it that you're telling the unit to let it choose which data set, which PID data set to function under, PID 0, 1, 2, or 3. Well, there you go, folks. There's a little more explorations with the Omega CN7500, more slanted towards a single set point control. All right, thank you for watching.